Welcome to The Explainer. I'm absolutely thrilled to have you here today, especially if you're the kind of person who just loves figuring out exactly how things work. Today, we're unpacking a really fascinating story of technological evolution. We're going to explore how a microchip, one originally designed just to make 1990s video games look a little bit better, completely reinvented computing as we know it. It literally became the engine driving today's massive artificial intelligence revolution.
NVIDIA CEO Jensen Huang has this incredibly profound way of looking at it. He says a GPU is like a time machine because it lets you see the future sooner. And honestly, that makes perfect sense when you really think about it. By making computing exponentially faster, his chips are allowing quantum chemistry scientists and medical researchers to finish what would normally take multiple lifetimes of work in just a few short years. So by speeding up these massive calculations, this tech is literally letting us see the future sooner.
Okay, let's dive into this. So what does the future actually look like? And how exactly do we get from the clunky, basic technology of the past to a future filled with autonomous robotics and superhuman AI? Well, to figure out what fundamental shifts made all of this possible, we actually need to take a quick trip back in time.
Section 1. From Gaming to AI, the 1990s Computing Problem.
So, to really understand this, we've got to transport ourselves back to the early 90s. Game developers had these massive visions for realistic 3D graphics, right? But traditional central processing units, or CPUs, just couldn't handle the complex math fast enough. Why? Because they solve problems sequentially, one by one. Think of that famous Mythbusters demonstration, where a robot paints a picture by shooting one single paintball at a time. It works, but it's painfully slow. NVIDIA realized rendering graphics needed a completely different approach: parallel processing. Their GPU is basically like a massive robot shooting all the paintballs at the exact same time. It handles thousands of smaller math problems simultaneously. And that was the breakthrough. That's what made those stunning video game worlds possible.
But here's where the story totally shifts, from just entertainment to genuinely changing the world. NVIDIA started noticing that researchers were trying to trick these gaming GPUs into solving really complex, non-graphics problems, stuff like fluid dynamics and CT reconstructions. So in 2006, NVIDIA took a massive, optimistic gamble and invented CUDA. CUDA is a software platform that essentially unlocked the GPU. It allowed any programmer to use standard languages, like C, to command all of that immense parallel processing power. They built it, basically just crossing their fingers and hoping the researchers would come.
Section 2. The 2012 AI Breakthrough, the Big Bang of Artificial Intelligence.
This right here is the climactic moment where NVIDIA's "if you build it, they will come" gamble paid off big time, fundamentally changing how computers work forever. So the crucial point is what happened in 2012 with a neural network called AlexNet. 3 researchers entered a famous computer vision competition and just absolutely crushed it. But it wasn't just that they won, it was how they won. Instead of giving a computer rigid step-by-step instructions on how to identify an image, they trained a deep neural network on a huge amount of data, using NVIDIA GeForce GPUs. For the first time, the machine was actually learning to recognize patterns entirely on its own.
Just look at how this chain reaction builds. You've got parallel processing unlocking gaming in the early 90s. Then, CUDA opens the doors to all programmers in 2006. And boom, AlexNet triggers the deep learning explosion in 2012. This specific sequence is what allowed researchers to rapidly conquer things like vision, speech recognition, and language comprehension, literally massive hurdles that had stumped humanity for decades. Suddenly, computers could actually understand the digital world.
But mastering digital text and image generation is really just step one. The next massive frontier? Physical AI. Which brings us to a huge question. How do we actually get AI out of the computer and effectively train robots to understand our messy, unpredictable, and sometimes downright dangerous physical reality?
Section 3. Training Physical AI, moving from digital text to the real world. Historically, training robots in the real physical world has been incredibly slow and expensive. You're limited by data collection from human motion capture suits, and it causes massive wear and tear on the machines. Well, NVIDIA's solution to this is Omniverse. Think of Omniverse as a highly advanced 3D digital simulation universe. But it's not just some video game level, it is strictly grounded in actual Newtonian physics. That means you can drop a digital robot inside this digital world and subject it to thousands of different lighting conditions, unpredictable obstacles, and challenging scenarios. It can safely train and learn without ever taking a single scratch of real-world damage.
But there's a catch, right? A robot also needs to fundamentally understand how our world actually behaves. Enter Cosmos. You can kind of think of Cosmos as a sort of ChatGPT for the physical world. It's a world foundation model that encodes physical common sense, things we humans just take for granted, into the AI. I'm talking about gravity, friction, and object permanence. It literally teaches the AI that if an object is sitting on a table and you look away, that object is still there when you look back.
And this brilliantly illustrates the new frontier of physical AI. By combining Cosmos and Omniverse, developers have created an infinite training loop. First, they generate infinitely many physically plausible scenarios in Omniverse. Next, the AI learns physical common sense via Cosmos, right inside the simulation. It runs through what would normally take days of physical factory training in just a fraction of the time. Then, only after it has completely mastered the digital world, is the fully trained brain placed into a robot in the real physical world.
Because of this incredibly accelerated training loop, Jensen Huang made a startling yet super confident prediction. He said, "Everything that moves will be robotic someday, and it will be soon." And he means it. We are talking about a very near future where autonomous lawnmowers, self-driving cars, and highly capable humanoid robots are an absolute certainty.
Section 4. Your superhuman future, thriving in the new computing era.
Now, it is totally normal to hear about a world filled with robots and feel a bit, well, apprehensive. But I want to reframe what this monumental leap in computing actually means for you as a focused learner. 10,000 times. Since delivering that very first $250,000 DGX-1 supercomputer back in 2016, NVIDIA has made AI computing 10,000 times more energy efficient. They are systematically removing the physical limits of innovation, making sure we have the computational energy required to power these incredibly smart systems sustainably.
So what are you actually going to do with all that power? Well, Jensen envisions a wildly optimistic future, where instead of fearing AI, we actually view it as our own personal R2-D2. Imagine having a lifelong AI tutoring companion that literally grows up with you. It moves seamlessly from your smart glasses to your phone to your car. It just eliminates the drudgery of mundane tasks, empowering you to tackle incredibly ambitious projects. It's like having a sidekick that teaches you how to be a better biologist, a sharper lawyer, or a more creative artist.
The core takeaway here is beautifully simple. We will become superhuman because we have super AIs. Having super intelligent tools doesn't make human beings obsolete. Actually, scratch that. Think about the invention of the interstate highway system. It didn't make travel pointless, right? It simply eliminated the drudgery of crossing the country, spurred the creation of new infrastructure, and unlocked entirely new economies. AI is simply the next highway system, but for the human mind.
I want to leave you with a provocative thought. We are standing right at the edge of a fundamental shift in what humans can achieve. So, if your AI tutor can eliminate the mundane drudgery of your work, how will you use your time machine? I highly encourage you to go interact with an AI today. Learn how to prompt it effectively, learn its language, and start figuring out right now how you are going to use this incredible new technology to build your own superhuman future. Thanks so much for joining me on this explainer. Keep learning, and I'll catch you next time.